Okay, let's look at the second half of the chapter. Again, we will just skim through examples here. I will explain the examples, and for practice, we will do the kit questions. Okay, so next we have is dispersion. We already saw mean and median, which told us about the center point of the data, but it didn't say anything about how wider or narrow the data is about its mean. So this is what we call dispersion. So how spread the data is around its mean. Okay, we have something called standard deviation. Standard deviation is a measure of how much data is away from the center point. We have two sets of data here. We have set 1 and we have set 2. If you look at set 2, it is less spread about its mean, because if you look at the center point, about all of these data is very closer to that 16. But if we look at data set 1, it is more spread. So how much the data is spread about its mean, there is a standard measure for it. We call that standard variation. The first step in calculating the standard variation is finding variance. And when you take standard deviation, the sign of which is this, and you square it, that becomes variance. You don't have to understand what is variance because it is a very complicated idea. But without the variance, we will not have standard deviation. So in the process of finding the variance, we find standard deviation. So what we do first is we find this part, and then we take the square root of that, which becomes standard deviation. The formula is given here for the standard deviation. This part will calculate the variance, and when we take square root of that, then it becomes standard deviation. So you might be thinking, why do we have to calculate the square of this and then take a square root of that, and that becomes standard deviation? For example, we have this 2 power here. So you might think that maybe if we remove this, then we don't have to take square root of that. But this will give you wrong answer. And there is explanation for that. I will not go into that much details. For now, just know that standard deviation measures the spread of the data. It shows how wide or narrow the data is spread around its mean. If you go into details, it will become complicated and you don't need it. Even at P4 level, these figures will be given to you. Okay, so we have an example here. The data and frequency, and then using the formula, the variance and then standard deviation is calculated. So first you will have to find variance, and then you will be able to find standard deviation. So again, I said, like we have 256 here, and then we take square root of that, it becomes 16. So you might be thinking, why do we take power 2 here? Why don't we directly take 37? but it will give you wrong answer. There is a reason for that. So for now, just ignore it. You don't need it. So yeah, it is calculated here for kit questions. If there is any question about calculations, I will do it. For now, the data is here. They've calculated it, and you just need to know how to put it in the formula. You don't have to know the meaning. Okay, coefficient of variation shows us the spread of the data about its mean. If coefficient of variation is higher, it means it will be wider spread. If coefficient of variation is smaller, then it would be lower spread. Like we have example here, we have one data where the mean is 120. We have another data where the mean is 125. Remember, mean is average. And then we have standard deviation of 50. If we take 50, 50 seems smaller than 51, but comparing to its mean, it is a higher percentage. So if we take 50 divided by 120, that gives us a coefficient of variation. So here we have 41%, here we have 40%. So this data is more spread than 50. Even though standard deviation of B is higher than the standard deviation of A, but in relation to its mean, it is more spread. Next, we have expected values. So we will leave this here. We will come back to this. Next, we have expected values. Sometimes in risk and uncertainties is used in situations when we are not 100% sure about the future, what outcome is going to be. One measure we could use to predict the outcome is expected value. Expected value is you look at the outcome and multiply by the percentage chance of it happening. And as an example here, we have a probability of 80%. We have a chance that something will happen 80%, and that is 5,000 profit. So 5,000 profit has a 80% probability, and 6,000 profit has 20% probability. We don't know whether 6,000 will happen, whether 5,000 will happen. This is the problem about the future. So one thing we could do is we could take 5,000 multiplied by the percentage, take 6,000 multiplied by the percentage. It will give us kind of an average figure. This is our expected value. Now the problem with expected value is it is not 100% going to happen. The outcome is going to be either 5,000 or 6,000, but it gives us kind of an idea. And expected values is used for decisions that is repeated many times. It is not used for one-off decision. So these are just introduction parts here. I will not go into too much details here because this expected value comes in F5. If you want to know about it in details, I've already made videos about F5. You can go to Risk and Uncertainties chapter and look at it in details there. So the second example, we had a probability of 10%, 20%, 60%, and 1%. Remember, the total of all probabilities should be 1 or 100%. And the expected value, it is going to be 5,800. Now, the problem with expected value is not going to 100% happen, but it gives us kind of an average, kind of an idea. Just like average doesn't happen, expected value doesn't happen. You have an example you could use here. Okay, next we have normal distribution. So in normal distribution, we are looking at how data is spread about its mean. If we have mean the center point, like in forecasting chapter, you have time series analysis, in which you draw a line of best fit, so that line of best fit becomes your mean, and the data above that line and below that line would be distribution. So one way of looking at how data is spread about its mean is doing it by normal distribution. Other methods are not examinable in ACCA. This is the only thing you need to know. So we have a center point, and then we have data spread here and data on another side. How this data is spread, one way it is known is through normal distribution. So 50% data is on this side and 50% data is on this side. That's why it is center point. So on an average, 50% data will be on one side and then 50% data will be on another side. It is a bell-shaped graph. Okay, it shows what these means and then how much percentage data is on each side. Okay, so we have 50% occurrence here below the mean, and we have 50% data occurrence above the mean. This is below the mean, this is above the mean. Just like when we have an average, 50% of the data would be below average, 50% of data will be above the average. About 34% below the mean has standard deviation of 1. How is it done? It is already found. You don't have to find it. That is why this table is given. So this is a working that has already been done. There is a calculation behind it. You don't have to know it. It is given as an example. You don't even have to memorize it. So about 34% below data, we have a standard deviation of 1, and 34% above data, we have standard deviation of 1. Collectively, it becomes 68%. And combined standard deviation would be 2. So a combined 2 standard deviation, or 1 on either side, will have 68% chances of happening. And likewise, 47.5% below the mean has 1.96 standard deviation, and 47.5% above has 1.96 standard deviation. Collectively, 95%. So 95% of the data will have a plus minus 1.96 standard deviation. Okay, so these data, you don't have to memorize them. They're already given in these tables, but they are standard. So what this basically means is that about 34% of the data, any data, will be above the mean. About 34% of the data below the mean about 34% data above the mean will have a standard deviation of 1, and about 34% below the mean will have a standard deviation of 1. About 47% data below the mean will have standard deviation of 196. About 47.5% standard data above the mean will have standard deviation of 1.96. You don't have to know this. It is already given in this table, and I will show you how you can use this table. Okay, this is the same thing as explained above. And this is how this percentage was calculated. Like we have 97% here, yeah? So when you add this together, it becomes 95%. You're just taking that percentage multiplying by 2, or just add these two percentages, it gives you that total percentage. Okay, prove that approximately 68% of frequencies have a value within one standard deviation on either side. You can do this using this standard distribution table. When we look at the percentage, if it is 68%, if you divide this by 2, why are you dividing it by 2? Because we have data divided on both sides. If you divide it by 2, it becomes 34. And if you check this 34% in the table, you will see that it has a standard deviation of 1. So there is no calculation involved. Whatever is given there, you just have to go and check it in the table. So sometimes percentage is given, so you have to find standard deviation. Sometimes standard deviation is given, you have to find the percentage. So for example, if they tell us what is the percentage of the data that will be above the mean, or what is the percentage of data that will be below the mean that has a standard deviation of 1. So you just look at 1 and then see what percentage that is. We have another example as well. You will look at it in a minute. Okay, so when percentage is given and you are finding the standard deviation, we call that z-score, just like it was done above. You take to find the z-score. Z-score is the standard deviation. You take the data, you minus the mean, and divide it by standard deviation. So like in this example, we have here, calculate the z-score and identify corresponding proportions using normal distribution. For example, we have A, the units are 100, and mean is 200, and we have standard deviation of 50. So we have a z-score of 2. So if z-score of 2 is given, you want to find percentage, you check 2 exactly, and you will find 47.2%. Above or below. If it says total area collectively, then you have to multiply by 2 or add it together. This other example, we had x 1000 minus 1200 divided by 200 gives you score of 1. And when you look at that, you can find it is 34.13%. Just like previously, percentage was given, we found standard deviation, the z-score, and here z-score is given, we find percentage. So for standard deviation, the z-score, you can find the percentage. For percentage, you can find standard deviation. Okay, we have another example that has all possibilities. All the way these questions could be asked. A frequency distribution is normal with a mean of 100, so we have 100 mean, and standard deviation of 10. Calculate the proportion of total frequency which will be above 80. So in all of these examples, we are given standard deviation or z-score, and we are finding a percentage. Z-score is not given, but we can calculate it, and this formula is given. So for the first one, we take 80 minus 100 divided by 2, it gives us, divided by 10, it gives us that score, which is already given here. I will just explain it. For practice, we will do the kit. So if z-score of 2, when we look at that in standard deviation, 2, it is exact 2, we have 47%. Now if you look at the question here, it says calculate the proportion of total frequency which will be above 80. So if 80 is here, which is below the mean, this whole percentage becomes above 80. Okay, if we calculate from here to there, then it becomes 47%. But it doesn't say up to mean, it says the whole thing. So 50% here and then 47% here. Let's look at the other one, above 90. The same calculation is done and we have a z-score of 1. When we look at z-score of 1, we have 34%. It said above, yeah? So it is done the same way. We have 34% here, which will become here, and then add the 50%, which will become 84%. Because it will be a little bit closer to the mean, so this area, this percentage is lower. And then the next one, above 100. So above 100 is the half, because mean is at 100. So above 100 would be this half. So you don't even have to calculate it, because we know that the mean is 100 and above mean is 100 data. Next is above 115. So 115 is above the mean. So this means this percentage would be less than 50%. So when the data is found, we have 1.5 standard deviation. And when you look at that in the table, we have 43.32%. Now, 43.32% gives you this percentage up to this mean. So this percentage that is given here, this is a percentage for this part and this part. So it shows you what is the percentage here. It shows you what is the percentage here. Okay? So we have 43.32%, but we are finding the percentage above 115. So it would be remaining, which is 50%, this whole thing, and then minus this percentage. So you have to be very careful in the question whether they're asking above or whether they're asking below, whether data is below the mean or whether data is above the mean. If data is below the mean, if they ask you above, it means they're asking the whole thing. If data is below the mean, if they ask below, they are only asking for this part. If data is above the mean, they ask above, they're only asking for this part. If they set the percentage below the mean, then it would have been this whole thing, which would be 100% minus this one. Okay, the next one, below 108, like in this example. So below 85, let's look at this one as well. Below 85, so below the mean, a percentage. So we have 85 here, this is below. So again, I will not show it. We have already seen how it is calculated, how it is found in the table. You take 1.5 and then search that percentage. So this is below. Next one, below 95. Below 95 would be higher area than below 85, because above 85, and if we look at above 85 and above 95, then above 95 percentage would be lower than above 85. But if you're looking at below 95, below 85, then below 95 would be higher percentage. Like in this example, we have 0.066, and in this example, we have about 36% below 95. Next, they could ask you in the range of 80 and 10, 110. So 80 and 110 would be somewhere here. So a percentage that is from here to there. So in this example, we have to find two things. One, a percentage from 80 to 100, and then a percentage from 100 to 110. This will be above 80, and this will be below 110. So two calculations are required. Yeah, we are looking at example of 80 and 110, which is H. So from 80 to 100, we have standard deviation of 2. It is already calculated. You can do your calculations. So this gives us 47%, which is an area from here to there. And then this other calculation gives us 43%, which is an area from here to there. You just add both, and that is your answer. And then 90 to 95. Like it would be somewhere here. Let's say if they ask for from 80 to 95, like in our previous example, one was 95, another was 80. Let's say they asked about 80 to 95. First we have to find the 80, then we have to find 95, and then minusing one from the other, we can find this part. So this is I. Okay, so in this example, they are asking 90 to 95. So first we are finding the 90 to 100, just like we would do for 80 to 90. And then we are finding 90 to 95. And then when we minus this part from it, the remaining would be this 90 to 95. Okay. So then there are some other examples that you can look at and do your practice. So next video, I will do kit questions relating to these.